Hello, ladies and gentlemen. Thank you for watching our presentation. I'm gonna start by introducing the group. We are Bárbara, Gleiciane, Júlio, Thiago, and Yasmin. We are students from Production Engineering of University of Brasília. The project that will be presented is part of PSP1 course. So, the idea of this project is to propose a solution for the long waiting line for elective surgery. This was a case of study from a real hospital from Brasília. Now I'll just list what I'm going to present. We'll start by a small introduction. I'm going to see what is happening in other countries. Then I'm going to see the methodology, results, conclusions, and the references. Elective surgery management ordinarily deals with a line of patients that must be allocated for surgery within a time period, considering both medical and monetary limitations. One of the main difficulties is that new requests for surgery arrive each day, so it can be complex to try to organize all these requests. Also, there is no certainty of how long it takes for each kind of procedure to be completed. We can also mention other limitations that comes from different kinds of problems, such as unavailable beds, insufficient medical staff, inadequate management, and even the stress of the hospital team. Since this is a very important issue, there is no doubt about the positive social impact on investigating this topic. This study is focused on suggesting an optimal schedule for the surgery rooms and the standardization in prioritizing patients of the hospital. All of this in order to optimize the surgery queue. Since there is no emergency surgeries in the analyzed hospital, those type of surgeries was not taken into account. In Sweden, there is a law that states patients who are scheduled for elective surgery can be put on hold for 90 days or less before the surgery is conducted. If the surgery is not possible within 90 days at the regional hospital, the hospital management is obliged to arrange and pay for the surgery at another hospital. The priority system from Sweden is normally divided into 3 priority groups. Priority 1 corresponds to the patients that has the greatest need for surgery, within 1 or at the most 2 weeks. Priority 2 are those patients that need surgery within 4 to 8 weeks. And priority 3 are those patients who need surgery within a reasonable time frame. The current prioritization in Australia divides patients into 3 categories. Category urgent are patients with a dysfunction that has the potential to become an emergency. The desirable time for admission is in 30 days. Category semi-urgent are those patients with some pain, dysfunction, or disability, but are unlikely to become an emergency or to deteriorate quickly. The desirable time for admission is in 90 days. The last category is non-urgent, that corresponds to the patients with a minimal or no pain, dysfunction, or disability, and are also unlikely to become an emergency or to deteriorate quickly. The desirable treatment time is at some time in the future. There was a program in Canada involving the government and research organizations that developed a method of prioritization. The Western Canada Waiting List Project came up with scoring tools to allocate patients. The final tools included clinical criteria and other factors, such as ability to live and work independently and ability to care for dependents. In addition to an extensive literature review, the research methods included interview with doctors, meetings with other groups that are studying the same topic to share information about the subject, and an analysis from the database that was provided by the hospital. For example, the list of procedures the hospital offer and the data from patients waiting in the line for surgery. The group developed two recommendations. The first one is a model to standardize how to allocate patients in the surgery queue. There is no doubt that the clinical criteria is very relevant when allocating a patient in the line. So, for example, whether the patient has a clinical health condition or not. But it was noticed that other factors should also be taken into account. For this reason, there are two phases in the scoring point model: the clinical analysis and the time waited in line. This model works based on the sum of points the patient has in each phase, so the patients with the highest number of points will take lead on booking a surgery. The second recommendation is to reformulate the surgery schedule. First, it was verified the amount of procedures that are conducted in the hospital. The procedures are, in this chart, divided by specialty. The higher number of procedures are urology, general surgery, otolaryngology, gynecology, and ophthalmology. And then, as you can see in this chart, the group analyzed the demand for each specialty. So the areas with a higher demand are general surgery, otolaryngology, urology, and gynecology. And other aspects that the group had to consider is that the hospital has 2 shifts per day, morning and afternoon, and the rooms are 13. There are 13 rooms, of which only 7 of those are actually working. So there are 70 shifts per week. The result was the recommendation as following the schedule in this table. All of the study leads to a conclusion that both recommendations should be implemented with careful monitoring and with an assessment of its validity, feasibility, and accessibility. The idea is to have constant feedback for improving the model. The group also believes that the big challenge for this model is for the recommendations to be accepted by the doctors and by the hospital administrators. Another conclusion is that the database should be reorganized, because the group also saw a lot of mistakes being made when filling in all the data from the patients. And it has already been said that this is a final project from one of the courses from production engineering. So the suggestion is for other students to follow the study in order to achieve a better solution for this complex problem. I would like to thank everybody that is following the presentation, and here is our references.